Dear students, myself Dr. Biswambhar Mohanty. Today we will discuss the experiment that is slide calipers. So that is the or vernier caliper. That is the aim of the experiment to find out the volume of a solid cylinder by using vernier caliper or slide caliper. So this is the slide caliper. Calipers means measurements. Since the vernier scale slides over the main scale, that is called slide caliper. And this the upper jaws and this the lower jaws, and upper jaws are used to measure the internal diameter, and lower jaws are used to measure the external diameter. And this strip is metallic strip is used to measure the depth of liquids. So first of all, how to calculate the volume? First we will have to calculate the diameter, then length. In a similar manner, it can measure the length. So the volume can be calculated by pi d square into h, volume of the cylinder, pi d square by 4 into h, that is the volume of the cylinder. So first we will calculate the diameter. How to calculate the external diameter? So first thing, we will have to calculate the least count. Least count, you just see, this is the 10 division, this is the vernier scale, and this is the vernier scale, and this is the main scale. This is the vernier scale, this is the main scale, and if the two jaws are in contact with each other, if there is no cylinder present between the two jaws, and if the two jaws are in contact with each other, then if the zero of the main scale coincides with the zero of the main scale. In this case, first thing you just see, 10 division on the vernier scale coincides with the 9 division of the main scale. This is the main scale, 9 division coincides with the 10 division of the vernier scale. And one main scale division is 1 millimeter or 0.1 centimeter. So 10 division, 10 via vernier scale division coincides with the 9 main scale division, and 1 main scale division is equal to 1 millimeter or 0.1 centimeter. This is the 1 millimeter. Here it is giving that 1 millimeter or centimeter or 0.1 centimeter. Centimeter or millimeter, you can say. So 1 VSD is equal to 9 by 10 MSD. And least count is equal to small a. Least count in the smallest measurement that can be made by the instrument, that is called least count. That is equal to 1 main scale division minus 1 vernier scale division. So 1 vernier scale division is equivalent to, that 10 main scale division coincides with the 10 vernier scale division coincides with 9 main scale division. 1 vernier scale division coincides with the 9 by 10 main scale division. So that is the 1 MSD minus 1 VSD. So that is 1 VSD is equal to 9 by 10 MSD. So in my instrument, so 1 main scale division is equal to 1 millimeter or 0.1 centimeter, and that is the 1 MSD minus 1 VSD 9 by 10 VSD, that is the 1 VSD 9 by 10 MSD, that is equal to 1 by 10 MSD. So main scale division is equal to 0.1 centimeter, so that is 0.1 by 10, that is equal to 0.01 centimeter. Yes sir, no? So this way you can find out the least count, and on the other ways also you may calculate the least count. Varieties of methods are there. This is the simplest approach, okay? And first thing, and it will two terms connect to each other. First thing, it takes the zero error. First thing, zero error. What is zero error? If the zero of the vernier scale coincides with the zero of the main scale, then that is no zero error. If the zero of the vernier scale is right to the zero of the main scale, then that is positive zero error. Zero of the vernier scale is right to the zero of the main scale, This is the 0 of the vernier scale is right to the 0 of the main scale. This is the 0 of the vernier scale, right to the 0 of the main scale, that is positive 0 error. And in this case, positive 0 error, what will happen? What we will have to do? Positive 0 can be calculated by least count into vernier coincidence. Vernier coincidence means the division, that is the division of the vernier scale that coincides with the main scale. Suppose the vernier coincidence means suppose if the two chairs are in contact with each other, suppose the vernier, suppose 5-6 division coincides with the main scale, that is the vernier coincidence 6. So you may calculate the least count and the vernier coincidence, that is the positive 0. That is the positive 0. Suppose the 6 of the vernier scale coincides with the main scale, then that the vernier coincidence is 6. And you have already calculated the value of least count 0.01 centimeter, and you calculate the positive 0. And the positive 0, how you will calculate true value, measured value? Just after calculating the positive 0, I will explain it. Then if the 0 of the main scale, the 0 of the vernier scale is left to the 0 of the main scale, but in my instrument there is no 0. That is the 0 of the vernier scale coincides with the 0 of the main scale. So if the 0 of the vernier scale is left to the 0 of the main scale, then this is called the negative 0 error. Negative 0 error means 0 of the vernier scale is left to the 0 of the main scale. Then this is called the negative 0 error, and this negative 0 error is calculated N minus Bc into LC. Bc is the vernier coincidence. That is the vernier coincidence means the division on the vernier scale that coincides the main scale, that is the vernier coincidence. And N minus Bc into least count we have already calculated 0.01. N is the number of division of vernier scale, and you have calculated the number of division on vernier scale is 10. So you may calculate the number of division of vernier scale is 10. You just apply 10 minus Bc. This is the vernier coincidence. Because this count is the negative 0. So how the positive 0 and negative 0, how it is utilized to calculate the real value or true value, I am just explaining it. So you just see. Suppose this is the diameter. Now my intention is to calculate the diameter, because the volume of a cylinder is pi d square by 4 into h. H is the height and this is the diameter. So how to calculate diameter of diameter? You just see, and you just first thing, just cylinder is placed in between the two lower jaws, and this the main scale is equal to 1.3. Suppose the vernier 0 coincides with the main scale, that is 1.3, that is 1.2, 2 and 3, in between 2 and 3. So main scale reading is equal to, that is the main scale reading is equal to 1.2 centimeter, that is main scale reading. And in this case you just see the vernier coincidence. Suppose the 6 of the vernier scale coincide the main scale. Suppose 6 of the vernier scale coincide the main scale, that is the vernier scale is equal to 6, vernier coincidence 6, and VSR is equal to vernier coincidence is equal to 6. Into least count we have calculated 0.01, that is equal to 0.06 centimeter. And the object value is equal to, in this case object value main scale reading, that is equal to 1.2 plus VSR is equal to 0.06, that is equal to 1.206 centimeter. So 1.206 centimeter. Then 0 error. So suppose in this case, suppose in my instrument there is no 0. Suppose the 0 error. Suppose 0 of the positive of the vernier scale, 0 of the vernier scale is right to the 0 of the main scale. Then positive 0. And in this case positive 0. Suppose positive least count is we have already calculated 0.01. And VC vernier coincidence. And vernier coincidence, suppose the 5 of the main scale coincide with the vernier scale. 5 of the vernier scale coincide with the main scale. That is, suppose it is 5. That is 0.05. That is the positive 0.05 centimeter. Then how to calculate true reading? And 0, that is the positive 0 error. So in this case positive 0.05 centimeter, and object diameter is equal to true reading, observed reading minus positive 0 error. So that is plus minus. So if it is positive 0 error, then the to calculate true reading, the positive 0 must be subtracted. So that is object diameter is equal to that is the object diameter is equal to, that is the correct diameter is equal to object diameter is equal to 1.206. This is the object diameter is 1.206. Since it is positive zero, so it has to be subtracted minus positive zero. If it is positive zero, then to calculate two reading, the positive zero must be subtracted. That is why that is equal to 0. This is the positive 0.05. That is the 0.05 centimeter. So this is the actual to calculate the correct diameter of a cylinder. Similarly, in the similar manner, we can calculate the height. And if you take the 10 observation, you can calculate mean diameter and mean height, and also calculate the mean, that is the mean diameter and mean height, and we can calculate the volume of a solid cylinder. Thank you very much.